Welcome to In 5 Minutes. In this particular video clip, we will discuss the circuit diagram and working of practical diode detector. We have already discussed the circuit diagram of simple diode detector, which we had called envelope detector in the previous video clips. So simple diode detector operates on the principle of envelope detection. We use it in the DSB-FC receivers because in case of my DSB-FC signal, the envelope of the signal is nothing but my modulating signal. So if I can extract or if I can detect the envelope of the incoming signal, that means I'm able to demodulate my incoming signal and get my original modulating signal back. But the circuit of simple diode detector is something we do not use as it is in the practical receivers. In the practical receivers, we use the simple diode detector, which is in the form of a diode, resistor, and capacitor. But there are some extra components also present. These extra components are required to perform some extra functions which we need in the practical receiver. So let us discuss the circuit of practical diode detector, how it is different from the simple diode detector, or in other words, what are the extra components which are present in this particular circuit. From the input side, my modulated signal will enter the detector. Now, if you remember, if you are using super hetero and receiver, which is a receiver used in all the practical AM receivers nowadays, if you use super hetero and receiver, then incoming signal, which is at carrier frequency, is down converted to intermediate frequency IF, and that's the reason the input to this circuit is being called IF. IF stands for intermediate frequency. Please remember that the down conversion has taken place only in terms of the frequency. The signal is still in the modulated form. It needs to be demodulated through the detector circuit that we are discussing right now. It enters into the detector. The circuit made up of capacitor and inductor on the input of the detector simply acts as a bandpass filter to make sure that the signal which is entering into the detector has the frequencies from IF minus FM to IF plus FM, which is in the band of 2 FM. It was FC minus FM to FC plus FM at the input of the receiver, but after the down conversion through mixer, now the same signal is present from IF minus FM to IF plus FM. To remind you, IF, which is intermediate frequency, is 455 kilohertz in most of the practical AM receivers which use DSB-FC signals. Once the signal enters into the circuit, you can see it has to go through the diode and capacitor. So this diode and capacitor, they form the simple diode detector circuit that we have already discussed. The resistor will be the equivalent resistance of the remaining part of the circuit. So we are not connecting any resistor R separately. Now, if you observe the practical diode detector circuit with the simple diode detector, we are placing diode in the lower branch this time. In simple diode detector, if you remember, I'll just quickly draw it here as a reference. We had placed diode in the upper branch, and then we had a capacitor and we had a resistor. And from here was entering the modulated signal, and my output was modulating signal. I can call it M of T. Now, when we place diode in the upper branch, we will be able to extract the positive envelope. In the AM signal, there are two envelopes, the positive envelope and the negative envelope. So when the diode is placed in the upper branch, we extract this positive envelope through charging and discharging of capacitor. This is what we had discussed before. Now if you place the same diode, if I take it from here and if I place it in the lower branch of the circuit, then everything remains same. The working, the way the circuit is going to work, everything remains same. But instead of extracting the positive envelope this time, because diode is placed in the lower branch, the circuit will this time extract the negative envelope. So capacitor will charge discharge with respect to the negative envelope this time. So my output will still be the modulating signal because any of the two envelopes will represent the modulating signal. This time my modulating signal will be coming from the negative envelope. You can see that the negative envelope is 180 degree out of phase compared to the positive envelope, which is not a problem, because if I simply provide that extra phase shift of 180 degree, then my negative envelope will exactly look like the positive envelope, which is nothing but my modulating signal. So we conclude that placing diode here in the lower branch will give us the negative envelope at the output side. Now the question that we will answer later on is that why do we want to extract the negative envelope? All right, we'll answer that little later. So we don't have to discuss much in terms of the working of diode and capacitor. They basically form along with the equivalent resistance of the remaining circuit, they form simple diode detector, the working of which we already discussed in detail.